Okay, so we've been looking at different ways to solve systems of linear equations. And the focus has been up to now on solving systems that involved two variables. And so in order to solve for two variables, we needed two equations. But we can take what we've learned about systems and go to that next level. And we can even look at solving systems with three variables and three different equations. Now, one of the methods we looked at for solving systems was the graphing method. So when we graphed with two variables, we had to look at two dimensions. You know, we had a horizontal axis, our x-axis, and we had a vertical axis, the y-axis. But if we throw another variable into an equation, say we have an x and a y and a z, now we're talking about having to try to graph in three dimensions. And so that's not possible, especially on a piece of paper. And so, because we're talking about then a dimension that would actually come up out of the page, so really we can't focus on the graphing method as a way to solve a system of this magnitude. And so we're really going to be focusing on using the two algebraic methods, the elimination and substitution methods, to solve systems with three variables. So let's take a look at some steps that we might follow to solve systems with three variables. So you'll see this in this example number one, you'll see this is what a three equation and three variable system might look like. And we're going to reference this as we go through the four steps. So when we want to solve a system like this, our first step is to choose two equations. So we have three, we're going to choose two equations in which we can easily eliminate a variable. So we're going to choose two to focus on at a time. And we're going to try to find a pair that we can easily eliminate a variable. And let's call this new equation after the elimination equation A. So we'll eliminate one of the variables and we'll call that equation A. Our next step is to then eliminate the same variable from a combination of the equation you didn't use and one of the ones that you did. So just pick a different pair of two. One will be an equation that you've used, one that you haven't, and we can call that equation B. We'll put equation A and B together. So now we've got these two systems, or these two equations in a system now that have two variables. So we've kind of brought it down to something manageable that we've been working with, and we'll solve that system. And so we'll be focusing on one of the variables there. And then now that you have, we can solve that system and we'll have those two variables that were in that system, say x and y, for instance, then now we can turn around and take those, put those back into or substitute into one of the original equations and find that third variable that's remaining. So let's go ahead and take a look at this first example and we'll kind of put these steps into practice. So let's say we just took the first two equations and we just focused on these two and we tried to eliminate one of the variables. Now it looks like the easiest variable to eliminate is going to be our y's. So if we take a look here at the coefficients on the y's, the top one has a -6 and the bottom one has a 1. And so what we're going to try to do is get them to be opposites of each other. So we're going to take this second equation and I'm going to multiply everything in it by 6, and I'm going to rewrite with my original equation 2x minus 6y plus 9z equals -8, and my new one that I created by multiplying by 6, which gives me 30x plus 6y plus 12z equals 60. And I'm simply going to just go ahead and add these together, just like I would do with elimination with two equations and two variables. So this way I'm going to get the y's to cancel out. I'll be left with 32x, no y's at all. My z's add up to 21, so I have 21z, and then add my constants together give me 52. So I'm going to call that equation A now, and I'm going to go over and write this off to the side as equation A. So now I'm going to do the exact same thing, but this time I'm going to target two other original equations. So I'm going to go back to my original, and I'm going to focus on the second and the third equation. I could really pick, the first and the third if I wanted to also, but I'm going to pick this pair down here, and I'm going to try to eliminate that exact same variable. So I'm going to try to focus on eliminating y, and actually it's pretty much set up so that I could just subtract the equations. I'm not really a fan of that, so I usually like to rewrite it so that they have opposite coefficients on the variable I'm trying to eliminate. So I'm going to go ahead and rewrite, this is equation 2, I'm going to rewrite equation 3 and I'm going to multiply through by -1, just to make it so that I can add instead. So that would make -3x minus y plus 8z equals positive 28 then. And I'm going to go ahead and add those together to eliminate the variable y. So I can do that again because, see, these are opposites. They are eliminated. When I add the x's, I am left with 2x. When I add the z's together, I have 10z. And then the constant terms add up to 38. So now I'm going to take this over and I'm going to call this equation B. And right here, equation B. And I'm going to combine it with the equation A. And I'm going to have a new, smaller, two-variable, two-equation system. And that are just describing x and z instead. So then I can focus on that. And this now becomes my focus. So I'm going to take a look at this system and I'm going to solve for x and z. So it looks like maybe the easiest way to solve this system is to maybe take equation B, and I'm going to multiply through everything in it by a -16 so that I can make the coefficient of the x's be opposites of each other. So rewriting it, so the first equation is 32x plus 21z equals 52. The second equation after multiplying through by a -36 or -16, is -32x plus a -160z, and that's going to equal -608. And I'm all set to add them. And so canceling out the x's leaves me with the z's, and the z's, 21 plus -60, I believe, is -139, so that's -139z, and adding the -608 and the 52 gives me a -556, and dividing by -139 will give us a value for z, and that turns out to be 4. So finally we have found the value of one of our variables, and so now we can go back and find x by taking this value, and we can plug it into one of the original equations, probably this one here, to determine what the value of x will be. So if I substitute in that 4 for the z into that top equation, which was originally called equation A, that's 32x plus 84 equals 52. We can subtract 84 from both sides, and that makes 32x is equal to -32. And now we can see that x is -1. So 2 down, 1 to go. So now we can find that final variable, the y, that's missing by taking these two values that we've already established for x and z and replacing them into one of the original equations. So at this point we can decide whichever one looks the easiest to us. You can choose any of them, and I'm just going to, for the sake of having just all positives, I'm going to pick that middle one, and I'm going to substitute in the values that I know. So I already know that the x is -1, so I'm going to plug -1 in for x. I don't know the y, that's what I'm looking to find. I know that the z is 4, and the constant, of course, is 10. Simplifying gives me -5 plus y plus 8 equals 10. Put my like terms together. Y plus 3 equals 10. And then I can subtract 3 from both sides, and I find out that y is 7. And now it's a good idea then to check and take these 3 and plug them into one of the other equations just to make sure that it works. And so feel free to do that, but I actually substituted it into this third equation there, and I was able to get both sides to equal negative 28. So I'm feeling pretty confident in my solution, and usually when I write the solution to a system, I'll write it as an ordered pair. So if I can find a spot to fit that in there, I put the x first, so that's negative 1, the y is 7, excuse me, and the z is 4. So that's my solution. And although it took a lot of work, and there were lots of opportunities to make algebraic errors, so you have to be careful, it was something that we basically just built on the things we had been doing and the processes we've learned for a 2 by 2 or a 2 variable 2 equation system. So we're going to go ahead and make number 2 an in-class example. So that leaves us one to do together when we're in class. And we're going to move on and take a look at some of our real-world problems. So taking a look at this application, the theater sells 3 types of tickets. So right away we see that there's going to be 3 variables, 3 different types of tickets. There are general admission tickets, there's senior tickets, that's senior citizen tickets, and children's tickets. Mark bought 9 general admission, 2 senior citizens, and 3 child tickets and paid $170. Sarah bought 5 general admission, 4 senior citizen, and 7 child tickets and paid $173. And Kyle bought 4 general admission, 1 senior citizen, and 6 child tickets and paid $116.50. Find the cost of each type of ticket. So basically each of those sentences that we just read is going to represent one of the equations in our system. And if we just set our variables, so general admission, say we call it G, senior citizen, maybe we call it S, and children's we call C, we can take each one of those sentences and convert it over into an equation. So the first one we're going to look at is the Mark situation, and Mark bought 9 general admission, so 9G, 2 senior tickets, and 3 children's tickets for a total of $170. So we talked the other day about the importance of maybe crossing out stuff that you use because there's a lot of numbers and it gets to be a little bit overwhelming. So now we've used all of those. And we move on to our next equation. So this one is Sarah's purchase. So Sarah, she bought 5 general admission, 4 senior citizen tickets, 7 children's tickets, oops, that's supposed to be a 7, and paid a total of $173. And finally Kyle. So Kyle bought 4 general admission, 1 senior ticket, and 6 children's tickets, and paid $116.50. So there's our system. We've got a system of 3 equations and 3 variables, and by the time we're done, we're hoping to find out the price of general admission, senior tickets, and child tickets. And again, not a bad idea to, as I was going along, I should have been crossing those out, just to know that I got each one of those numbers into my system. So let's kind of review that process. So what we want to do to solve a system like this is, first of all, we want to be very careful, but we want to pick a pair of the original equations and just focus on 2 at a time. So I'm going to pick the first and the second, and then we want to decide on a variable to get rid of. And so I would like to try to eliminate the s's. And so currently one s is 2 and the other is 4. And that means what I'm going to do is go ahead and take this first equation and I'm going to multiply the whole thing by -2. And then I'm going to rewrite it. So if I multiplied everything by -2, that's negative 18g plus negative 4s plus negative 6s equals negative 340. And then I'll also rewrite that second equation, 5g plus 4s plus 7c equals 173. And now I'm set up to go ahead and just add these equations to cancel out one of the variables. So you can see that the s's are going to cancel their opposites. When I add the g's together, I get negative 13g. When I add the c's together, I get just plain c. And when I add the constant terms together, that turns out to be negative 167. And remember, that's going to be called equation A. So that's going to be part of that new two-equation, two-variable system that I'm going to eventually use to solve and find my first two variables. So I'm going to rewrite this down here as equation A and go to work on getting a second equation to go along with it that just contains G and C. So now to do that, I'm going to focus on the next two equations. And again, I want to eliminate the exact same variable, so now I'm going to try to eliminate the s's again, but this time I have one that has a 4 and the other one that has a positive 1. So I'm going to take this bottom equation down here and I'm going to multiply that whole bottom equation by negative 4 so I can get them to be opposites, and then I'll rewrite them and solve that system. So the one that starts with the 5g plus 4s plus 7c equals 173. And then that bottom equation that we're multiplying by negative 4 becomes negative 16g plus negative 4s plus negative 24c equals negative 466. So negative 466. And now I'm ready to go to work. I'm going to go ahead and add those together. So my s's will cancel out. And when I add my g's, I have a negative 11g. And when I add the c's together, I have a negative 17c. And the constant terms, negative 293. And that becomes equation B, because what's remaining has just G and C, and that's what my equation A has as well. So I'm going to rewrite that down here, and I've got my new two-variable system that I can start then focusing on to find those two variables in the methods that we learned in a prior lesson. Now clearly you can see one of the issues that can come up when we're doing something like this algebraically is there's a lot of opportunities to make sign errors. So I just would really encourage you to just be very careful, watch signs, because one mistake along the way can completely throw you off. So now we're down to our little system here that has equation A and B in it. It's just a 2 by 2, and we can start working on that. So it looks like probably the easiest thing to do is to try to multiply this top equation by 17, and I can get my C coefficients to be opposite of each other. So this is why we give so much space, just 2 questions per page most of the time, because these obviously take a lot of space to work. So when I rewrite this one, that will be, let's see, that's negative 221g plus 17c equals negative 2839. And then my other equation can stay just the same as negative 11g plus negative 17c equals negative 293. And it's finally time to solve. So we're going to add these together. The c's will cancel out. I'm focusing just on the g. And my coefficients add up to negative 232g, and the constants add up to negative 3132, and all I have to do is divide both sides by negative 232, and that turns out to be 13.5. Or in terms of our situation, $13.50. Because of course we're trying to find out the cost of these tickets. So general admission, $13.50. We can take that G and we can plug it into one of the original equations up here, A or B. So I'm going to take it and say plug it into this one right here, and then we can find out what C is. So when I multiply that by negative 13, so negative 13 by 1350 is negative 175.5, and all I have to do is then add that to the other side. So when I add 175.5 to negative 167, that turns out to be 850. And so now I've found that C must equal $8.50. So now I know children's tickets. So now that I know children and I know general admission, my final thing left to do is to find out what senior citizen tickets are. And so we're going back to one of the original equations, and probably the smartest one to pick is going to be this one right here, because that looks like that has the easiest S value. It's just got a coefficient of 1. So if we take the two numbers that we've already found and we plug those in, so 4 times G, so 4 times 1350. This part right here is going to give us $54 plus 1S, S is what I don't know, plus 6 times, oops, that was supposed to be a C, and I never noticed that I wrote that wrong up there. Sorry about that. That was supposed to be a C, way back at the original. And then we have 6 times the 850, which is the children's ticket price, and that turns out to be $51. And that's all got to add up to $116.50. So all we have to do is simply subtract the 51 and the 54, which add up to 105. So I have to subtract 105 from the 116.50, and it's going to leave me with 1150. So let's see if I can find a spot to fit that answer in. So S, down here, senior citizen tickets are $11.50. And so now we've been able to go through this process and answer the question, what are the prices of each of the types of tickets? So there are a couple real-life examples left, but we're going to save those to, again, give us opportunities to do some of those together in class. So that does it for today.